Welcome to Panel Educate. In this video series, we'll be looking at probability. And I'm expecting at the end of this video, you should be able to explain the probability of events. And also you'll be able to calculate the probability of an event and solve simple problems on probability. Now, probability is a branch of mathematics that deals with the possibility or chances of events occurring under stated condition. For example, there are so many activities that we have on a daily basis that requires probability. For example, the referee choosing which team to start a match, to kick off a match, using a coin, to toss a coin to check, if it's going to be head or tail for whoever that will start the match, or if they want to choose which side the players must play from the beginning of the match. We also have referee choosing which team to kickstart a match. I've talked about that. We can have fortune tellers making prediction to their clients. We can also have consultants of gynecology and obstetrics. Those people that are specialized doctors for women, making forecasts for the sex of the children. So these are the example that we can give. Okay, now probability values range from 0 to 1, and a value of 0 is from 0 to 1. Then a value of 0 represents the event that is not possible at all. The event that is not possible at all. For example, the probability of a man becoming pregnant is 0. Okay, that means the event cannot happen. Okay, we can also have the probability of a woman being a priest, in a Catholic church. So all this probability is 0 because no woman can actually be a priest in Catholic church. It's not possible. And we also have the probability of a value of 1, which stands for a must happen event. The probability of an event that is certain. For example, every human being must die. Every human being must die. That is certain. That is a probability of 1. Or we want to say that every family in Nigeria must at least have one person. Either female or male, in that family. That's the probability that is certain. So we have all this probability like that. So all these events that have probability 1, they are events that are certain. All right, so but we have, we said probability, the one that is not certain is 0, the one that is certain is 1. So we also have everything, all the occurrences. Okay, all the occurrences, they are either they fall between 0 and 1. Now, if I say that a referee is to toss a coin to determine who starts a match, which team starts a match in a competition. All right, so and the coin will have either head or tail. All right, so the probability of a success that somebody will take the head will be 1/2, because we have two sides. It's either head or tail. Okay, that is someone that will have head, pick head. Okay, then that the coin that will be tail is also 1/2. So if you add this probability together, half plus half, you get 1. Okay, so what we have is that the two outcomes, when you add the two outcomes of the two coins that is tossed, either head or tail will appear, and if you add it together, it's going to give us a 1. And also, if you have the probability of when you throw a die, don't forget that a die we always have, either 1, 2, 3, 4, 5, 6 in the face of a die. Okay, the die looks like this. Okay, so you can have 1 here, 1, 2 here, so then the probability, because the size are 6, so the probability of us, when we throw a die that will get a 1 is 1/6. The probability of when we throw and we get a 2 is also 1/6. Okay, so if we add all these events happening, either is 1, either is 2, they are all 1/6. If you add all the 1/6 together, 1, 2, 3, 4, 5, and 6, this will also give you a 1. All right, so the probability of obtaining either 1, 2, or 3, or 4, or 5, or 6, in each case, so once you sum it up, it's going to give you a 1. Now, let us look at relative frequency. So let us examine experiments whose results we cannot predict, right? So the result that we cannot predict, such experiments are usually called random experiment because we cannot predict. For example, if we toss a fair coin, we may not be able to say for sure whether that coin will land with head or with tail up. So we are sure a fair die will land. We know that that one will land, only that we're not sure which of the faces, either 1, 2, 3, 4, 5, or 6. We are not sure of which of these faces will land. So this kind of experiment of tossing coin or a die, they are example of random experiments, like I explained in the previous slide. So it's a random experiment. Now, if we toss a fair coin 100 times, so the experiment has shown that in most instances that the number of times a head shows up will be very, very close to 50. So if we denote the number of times that we are successful in having head, that's the number of success. If you denote it by NS, right, then N into T we denote it with number of trials. So the probability, which is the ratio, will be number of the success over the number of trials, which define the probability that a head show up. So this ratio of n number of s over number of time with the trial is also called the relative frequency of the number of times a head show up. So the empirical definition can be regarded as the relative frequency definition of probability. So we have the number of events, even the success, right? Then we have the number of the trials that we can have, right? So that will give us the relative frequency. Now, let's check the next one, the sample space and event space. So any result of an experiment in probability is called an outcome. So we need to take note of that any result of an experiment in probability is called an outcome. So if we cannot predict the result beforehand, the outcome of an experiment is called a random experiment. Like we said that, okay, if you cannot predict the event, like the tossing of coin or the throw of a die, or tossing of die, we cannot prevent it. So we call that one as random experiment. So the sample space, they are set of all possible outcome of any random experiment, and it is denoted S. All right, so the number of outcomes in S, which is the sample space, or the number of elements in the sample space, is denoted as this. For example, A subset, okay, no, let's check the subset of the sample space, which may be a collection of outcome of a random experiment, is called an event space. Now, let's denote the event as E. So if the event that is going to happen is E, okay, and the number of outcome or elements in E as this. So if the event is E, right, if the event is E, then the number of outcome, that's the number of elements in E, is noted as this. So the probability of an event E happening is the number of the elements over the sample space. The number of elements over the sample space. Now, what do we mean by that? Okay, now let's look at Equi probable sample space. If we toss a fair coin, a head has an equal chance of appearing as tail. That one is certain, which I said before, which is half. Also, the die also, if you toss it, for all those things to occur, you can have 1/6 for each of the 6 sample elements. For example, for the for the fair coin, you have 3, 4, 5, 6. Okay, here you have the number of sample space, okay, to be 6, right? So, and the probability of an event happening, which is E, for a 1 to occur is 1, which is the element over the sample space, which is 6. All right, so it means if a sample has n sample elements, we can assign the probability of 1/n for each of the elements in the sample space. So these are elements in the sample space, but the sample space is 1, 2, 3, 4, 5, and 6. So the sample space to which we assign each of the sample elements equal probability is called equiprobable sample space. Don't forget that for each of these elements occurring, coming up when we toss the coin, is just 1/6. All right, the elements here over the sample space, which is 1, 2, 3, 4, 5, 6, which is 1/6. Now, if we look at this example, we said in a single throw of a fair coin, find the probability that a head appears, a tail appears. Now, the sample space, let the sample space be S. All right, so the sample space is either head or tail. So our sample space, NS, is 2. All right, so let E1 be the probability of event that head appears. So probability E1 is the probability that head appears. Okay, so, and the sample space for E1 that it appears is 1, can only be 1. So don't forget our probability, of E1 will be the number of sample space of E1 over the sample space. That's the number of elements in E1, then over the sample space. So we have the number of elements in E1 to be 1, okay, which is this. Then the sample space, is 2, which we have gotten here. Then we have 1/2. Same can be applied to if the event that the tail will appear. Also, E2 be the event that tail appears. Then we have the sample space. That's the number of elements in E2 is 1. Just this sample, this one alone. All right. So then the probability that E2 appears is the number of elements in E2 over the sample space. So which is number of elements in E2 is 1, right? All over 2, which is the sample space. Now, as discussed, the probability of an event probability of an event happening is equal to the number, that is the number of elements in the event, number of elements, or the number of events divided by the sample space, right? We've discussed that as number of sample space, okay? Or we say the total number of ways in which the experiment or the result can happen. That is the total number of elements in the sample space. So let's look at this particular one. So in a single throw of 2 coins. So in this particular case, I'm going to do like this for me to get what is contained in my sample space. So I have head, tail for the first one. Okay, let me do like this. Okay, I have, let's say, head here and I have tail here. Okay, then the second one, that's the second one, I also have head, tail. Now if I throw the two together, I can have head, head. Okay, in a single throw, can have head, tail. In a single throw, can have tail, head. In a single throw, we can have tail, tail. In a single throw of 2 fair coins. So now all these elements are here: head, 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 tail, tail, head, tail, tail. They are the elements in the sample space, and that's why we have this 1, 2, 3, 4. So we have 4 elements in the sample space. Then we have to find the probability that 2 heads appear. So if we represent the probability of 2 heads appear with E1, right, then we're going to have the number of elements in E1 over the sample space. All right, so now that 2 heads appear, so we only have this only one time that we can have as 2 heads appear. So the number of elements that 2 heads appear is 1. So our answer is 1 over 4. This 4 is the sample space. Then 2 tails appear. This is the only time that 2 tails can appear. This is the only time 2 tails can appear. So it's also 1 over 4, which is the same sample space. Now, 1 head and 1 tail appears. The probability that 1 head and 1 tail appear. Now, if you look at this, you discover that this is 1 head and 1 tail. This is another 1 head and 1 tail. So we have the probability of such events, that means the number of elements in such events, they are actually 2. Okay, probability of such event, they are actually 2. So the number of the elements within that particular E3, which is the event that 1 head and 1 tail appears, is 2. So and our sample space is 2. So if we do 2 over 4, then the probability that 1 head and 1 tail appears is half. All right, so let's look at another example. Okay, we have a 2 fair dice are tossed, 2 fair dice are tossed, and we should find the probability that the total score that shows up is 8, or the probability that the total score is less than 6, greater than or equal to 9, and we have the probability that a prime number occur. Now, in the sample space, where we have a coin, don't forget we're going to have 1, 2, 3, 4, 5, 6. Then you go to have another one, 1, 2, 3, 4, 5, and 6. So we have to find the probability that the total score that show up. So that means we are adding. So if you throw the first one, we can do 1 plus 1. This will give you 2. 1 plus 2 is going to give you 3. 1 plus 3, 4, 5, 6, and 7. Okay, you can throw it and you're going to have 2 and 1 will give you 3. 2 and 2 will give you 4. 2 and 3 will give you 5. 2 and 4 will give you 6. 2 and 5 will give you 7. 2 and 6 will give you 8. like that. 3 and 1 will give you 4. 3 and 2 will give you 5. So if you do everything here, you're going to have this. Okay. Now, let us now look at the probability. That's how that one is. We're going to find that one because we are talking about the addition. All right. So we're talking about the addition. That is, if the total score that shows up, the total score, that means the addition. Now, we're saying that to find that the total score that show up is 8. Okay. So the scores that show up, there are 8. Let us look at it. We have in this line none, in this line none. Here we have 1. Okay, we have 1. That's 1 8 here. 2, another 8 here. 3, another 8 here. 4, another 8 here. 5. So the event that the number, the total score, if the event is A1, okay, so the event that total score is 8, we just have 5, okay, because we have 5 8s. Then the sample space of it, if you look at it, 1 2 3 4 5 6 7, if you count all this, the sample space is 36. So the probability that the total score that show up is 8 is 5, which is number of elements. Okay, the number of elements that shows that there are 8, then over the sample space, which is 5 over 36. All right, so let's look at, so we want to look at the number less than 6. So let us look at the numbers that are less than 6. Okay, we have 1 2 3 4 5, okay, 6 7 8 9, okay, 10 11 12 13 14 15. All right, so we have the total number, the event that total score that show up is less than 6. The total score that show up is less than 6. So we have this one, 1. Let's do it again. 2, 3, 4. That's less than 6. 5, 6, 7, 8, 9, 10. All right. So we have 10 that shows that. Don't forget that this particular one is the first die. This is the first die. This particular column is the second die. This particular row is the first die. So all the addition that you have here is what you're going to use, and we're able to count 10. All right, so then that means our sample space of events E2, which is the number of the total score that is less than 6, is 10. And don't forget our sample space for all the events is 36. All right, so if we do that, we have 10 over 36. We have 10, okay, over 36. These are 10 over 36. And if you do that, give you 5 over 18. Now, we're to find the event that total score that show up is greater than or equal to 9. Let's look at that. Greater than or equal to 9. So let us look at the event that is greater than or equal to 9. So let us look at that. Greater than or equal to 9. Okay, from this place we have 9 here. 1. Okay, we have 2, 3. Okay, 4, 5, 6, 7, 8, 9, 10. So the sample space for the event that is greater than or equal to 9 is 10. Okay, so we have 10. Then don't forget our sample space. This is an event that is greater than or equal to 10, equal to 9 rather. Then we have our sample space over 36, so it's 10 over 36, and probability is 5 over 18. All right, so then we want to find the probability that the total score that show up is a prime number. Prime number is any number that is divisible by 1 and itself. Meanwhile, 0 and 1, they are not prime numbers. So let us look at total score that show up is a prime number. All right, so if it's a prime number, so let's go back to the table, okay, and we're to check which one and which one is a prime number. Okay, we have 3 is a prime number. Okay, let's go again. 5 is a prime number. That's 2. So 3, this is another 3, 3, 5, and 7. We have another 3. Let's start again. This is 3, 5, first one, and 7. We have 3, 5, 7. In the first one, 1, 2, 3. Then the second one, we have 3, 5, and 7. That's another 3, 5, and 7. Okay. Then this one, 2. In the third row, I have 5 and 7. Under 5 and 7. Okay. That's 1, 2, 3. Then the fourth row, I have 5, 7. Okay. I have another 5, 7. That is 1, 2, 3, 4. Then the fifth row, I have 7. Okay. And 11. I have 7 and 11. And in the last row, I have 7 and 11. Another 7 and 11. So if you count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, which other one that we have not gotten? Oh, we have 7 and 11 here. Okay, so the total number of all the events that the sum are prime number, they are actually 15. Okay, look at it. Let's look at it again. 15. We have 1, okay, 2, 3, 4, 5, 6, okay, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Yeah, sorry, I didn't pick this 2. That's 2. 2 in the first one. That is 2, 3, 5, and 7. So that makes it 15. All right. So those are the prime numbers. So that's 15. We can then say that you know that our sample space, okay, is still 36. Then we have the events which we have as C4. That's 15. The total score that show up actually prime number. So we have 15 over 36, and our um, probability for the event, the total score that show up is a prime number is 5 over 12. All right, so let's look at this particular example. But before we do that, don't forget I said the set of possible outcomes or result is called a sample space. That the set of possible outcomes or result is called a sample space, and each possible outcome is called an event. Okay, that could be an event that head will occur, when that tail will occur. Right, this particular one of a toss of a coin is this particular one is a sample, a sample, a sample space. That's head, tail is a sample space. Okay, now let's look at this example. We said a fair die with 6 faces, numbers 1 to 6, is tossed twice. Tossed twice. So this is the first one. This is the second one. Now, obtain all possible outcomes of the magnitude of the difference between the numbers showing. Okay, so the possible outcome of the difference, that is negative, the difference here, right? So we should obtain all the possible outcome of the difference. So 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. Okay, 5 minus 1 is 4. 6 minus 1 is 5. Okay, 2 minus 1, 1. 2 minus 2, 0. 3 minus 2, 1. 4 minus 2, 2. 5 minus 2, 3. 6 minus 2, 4. So you do that for all of them, while you are subtracting the smaller number from the bigger number. So that's how you get all the possible outcome of the throw. So this is the first throw, and this is the second throw in the second throw in the column here. So the first throw is in the row. Okay, so now we are asked to find what is the most likely difference and its probability. What is the most likely difference and its probability? Now, the most likely difference is 1. Okay, what is the most likely difference? Okay, so we have this 1, we have this is 2, this is 3, okay, this is 4, 5, 6, 7, 8, 9, and 10. All right, which is the most likely difference between the two. So the 1, it can occur in 10. Let's look at the other ones. We have this 1, okay, 2, 3, 4, 5, 6, 7, 8. All right, 2 occurs 8 times. Okay, let's go at 3. 1, 2, 3. Okay, 4, 5, 6. Okay, 3 occurs 6 times. Okay, let's look at 4. We have 1, 2, okay, 3, 4. Okay, 4 occurs, that's 4 times. What about 5? 1, 2. All right, so 5 occurs 2 times. So the most likely difference, which is 1, it occurs 10. That's the most likely difference. That means the difference that occurs most in the outcome. All right, so we have 1, so that's the 10. So we have 10. So our probability, okay, of E1, that is most likely difference, which is 1, is equal to the number of E1 over the sample space. So in this case, we have our sample space to be 36. We count all the numbers here, that's 36. Then we have 10 over 36. So this one is 2, is 5. 2 here, that is 18. So we have 5 over 18. Now, another one is let E2, that's we are asked to find the event space for a difference of 2. And what I counted the other time for the difference of 2, we have 8. Okay? All right, so 8 over 36 is going to give you 2 over 9. Then they're asked to find the mean. Okay, find the mean, that's the mean difference. So what we're going to do for that is to sum up all the magnitude of the differences. Okay, we're going to sum up all the magnitude of differences inside it. So if you sum up everything, like this one 0 plus 1, this is 3, 6. Okay, this is 6. This is 10, this is 15. So if this is 15, then you sum all this one to 2 plus 1, 3, 3 plus 1, 4, 4 plus 2, 6, this is 9. So if you sum everything together, you're going to have 70. Those are 70. All right, so, and 70, that is the sum of the mean. I mean, that's the sum of all the outcomes, then over the sample space, which is 36, and that will give you 1.94. All right, so I'm going to pause this video for now while we continue next week with the part 2, and we'll be starting with combination of events. I want to subscribe to our YouTube channel. Please share with your loved ones and friends, and we'll be expecting feedback from you. Please comment. Let's have your comments, and we'll see you next week. I hope this video has been very informative. Bye.